Good morning and welcome to our 2 days webinar regarding high production with VSC machines. My name is Heiko Meyer and I welcome you today together with Peter Gröner. Peter Gröner is the team manager in the quotation team for vertical pickup machines at EMAG, and he can take a look to more than 20 years experience with the VSC machines, where he presenting to us mostly interesting aspects of these machines. Like usual, you have the chance in the webinar to ask directly questions to us. For this, please using the chat function, and we try to answer you the question during the session. That's from the beginning from my side. Please, Peter, starting.
So, Heiko, thank you. So I start with a short introduction. A very brief historical excursion. In 1992, EMAG introduced the first vertical pickup turning machine. The idea behind was to build a self-loading turning machine. This means the main spindle and also therefore the chuck, which is assembled on the main spindle, moves to the workpiece and picks it up from the automation system. The workpiece then moves to the tool and the turning operation is done there. The workpiece performs all movements. We have integrated quality then in the machine. This means the quality check can be carried out directly on the workpiece using a measuring probe, not indirect via a tool measuring system or later in the line via a post-process gauge. We have a free chip fall. This means chips no longer remain on the cover of the inclined machine beds, but falling direct down between the machine body into the chip conveyor.
Okay, a short overview about the technical data, workpiece dimension on the machines. We have in totally 4 different sizes available. We're starting with the VSC 250. There we have a chuck diameter of 315 millimeters, where we can do then workpieces up to 250 millimeter diameter. And we going up to the biggest series machine of the VSC series is the VSC 500. There, like the name is, we have the chuck diameter 500 and maximum workpieces are possible with 440 millimeter diameter. And all the others, that the other machines are between. And how looks like the machine regarding the concept, the design, Peter will give us now more detailed informations.
We will now show you the advantages of the VSC series and possible features for your production. We start with the machine body, and we're using here the VSC 250 as an example. We start with the machine body. The machine body has 2 side walls and essentially looks like an U shape if you look direct from the front onto the machine. The cross slide is then placed on top of this. The machine is molded from mineralite, which is a polymer concrete. The fastening elements, for example, for the linear guideways, for the turrets and so on, are also molded in and are therefore already integrated in the machine body. In contrast to a machine bed made from cast iron, the vibrations are reduced more quickly in the mineralite. You see this here in the 2 small pictures on the below end of the slide. We have on the left side the mineralite vibration and on the right side the cast iron vibration. The chips fall directly through the machine bed into the chip conveyor.
Peter, there is also directly was fast asked question. If we have this mineralite bed, what effects does the mineralite bed have on the tool life? Because we have this good dampening behavior of the mineralite bed.
Yeah, because of the vibrations are stay not as long in the structure as on the cast iron. We have better cutting conditions. We have a more stable and rigid condition, and therefore the tool life is longer than on comparable cast iron machine beds.
Then that's also important point. Can we say, okay, that's some number how better the tool life are compared to cast iron machine beds?
This is difficult as there are so many points which will influence this. It's the work holding, it's the cutting conditions, it's the cutting material. So it's not so easy that we can say this is this weight or not.
But fact is, we provide with the mineral bed the best preconditions that we reach high tool lifetime. Yeah?
Yeah.
Okay, thank you for answering these questions.
So then we have hydrostatic guiding on our lower Z-axis. You see it here in the small animation. There is a ring around our quill, and this is filled by hydraulic oil. So the cross slide itself sits on the top of the machine bed, more or less like a gantry. The lower guide of the Z-axis is equipped with this hydrostatic bearing, and therefore the spindle sleeve or the quill is surrounded by an oil film and moves up and down in this oil film. Therefore we have no friction and we have no wear on the quill. The oil film also dampens the vibration, especially during the hard machining and in interrupted cuts.
And Peter, if I can ask you here the question now, one more positive thing for high vibration dampening and stability is the hydrostatic guideways in the Z-axis. And what is also important for the stability is the size of the bearings which we're using on this.
Yeah, and for example, on the front bearing on the VSC 250 we have 110 millimeters, and on the VSC 400, just an example, it's 160 millimeters.
Okay, so really rigid and stable machine design.
We will continue. We have a symmetrical design of the machine. This means the cross slide sits on the U-shaped body with the two sidewalls. Also on the VSC 400 size there is a Y-axis available as an option. The cross slide sits on the bed like a gantry and therefore closes the base body from above. The result of that is a closed flow of forces, which we see here in the blue lines. The X-axis sits symmetrically on the base body, as well as the Z-axis is exactly in the center of the cross slide. Thermal elongation can thus be easily compensated for. We have a high long-term accuracy because of that inside the machine. And you see here in front the turret of the machine, and this turret is also mounted in the machine bed by 360 degrees. Because of that we have very short levers between the last assembly point in the machine body to the point of contact of the turning tool. The VSC series is equipped with motor spindles. The motor spindles are mounted on 3 bearing levels. The motor spindle itself is installed in the slide of the Z-axis, and we have a symmetrical design here also. The motor spindle is cooled by a cooling fluid, and on the large VSC 500 Duo we have also a hydraulic counterbalance to compensate the weight of the spindle and the slide.
Peter, there is, for me, if I can step in shortly, what is important, we saw now the spindle, we saw already the mineral bed, machine bed, we saw the hydrostatic bearing, and what is important here, all these components which are important for the accuracy of the machine, we producing by ourselves. Yeah? The mineral bed will done, the spindles, really from the basic machining of the shaft for the spindle, everything done in Zerbst. Zerbst is located between Berlin and Leipzig, where we producing most of our basic machines for the whole EMAG group, and that's every time too impressive to see this. That's only some side information, what also to know to understand our philosophy. And there is one more question regarding the spindles, Peter. What's happened if the spindle fails? How long is the downtime?
Yeah, if the spindle fails, we can check if we can get it fixed direct at the machine, or if this is not possible, we can replace the complete unit and replace it by a spare system. And the defective spindle then is can be retrofitted here in our, for example, in our facility in Eislingen, and is then in stock ready if another machine fails.
Okay, then we have here exchange spindle stocks with complete spindles, which we can send immediately to the customer to shorten the down times. Okay, thank you for this additional information.
The machine has a cooling circuit to cool the machine body, the turret and the spindle. The hydraulic oil is also tempered via a heat exchanger. The control cabinet is cooled by a separate cooling unit. The machine is not just cooled. With the help of a sensor, we follow the ambient temperature in the shop floor. Heat exchangers can also be used instead of the cooling unit if there is a cold water network already installed in the production hall. In this case, you can use the heat which are produced by this machine as, for example, as heat to heat up a washing machine or to heat up your offices or whatever.
Okay, then also important point under high series production are the quality inspection. Like you see here on the video, on each machine we can assemble or mounting measurement probe outside of the work area. What we can do with this then, with this probe? With this probe we can, for example, measure the first part after a tool change or after a setup and then make the necessary corrections. Or we can also, if we say, okay, that tolerance is critical, so we can tell the machine, okay, measure every fifth part and make then the correction to hold the tolerances stable. What is clear, this due to the fact that the parts are measured, clamped inside the spindle, you have the influence from the clamping, and as well, it's in addition to the machining time. You cannot measure here with this probe in the idle time, so that's an add-on. So it's not helpful if you measure 100% with this probe, but it's important for the setup, calibration after the tool change, and so on. And also one more point is, if you have a orientation to do in the workpiece, for example, there is already a groove there or a hole where later matched to another hole, for example, you can check the position of the hole and make then the orientation of the Z-axis accordingly. That's also an important point. But we have also to keep in mind that the measurement capability for such probe is not official. So you have no certificate for this measurement probe. So if your customer asking you for a measurement certificate, you cannot prove it with a measurement probe on a VSC machine. For this then you need a post-process measurement unit close to the machine or go to your measurement room. These PPM solutions which we are add to the machine, we are as well possible to do this so that you have directly a closed loop to your machine, give the feedback what you have to correct and so on. But these are all important points to getting long life or long time quality with the VSC series. That's from the quality aspect, please, Peter, have you to add something here? Or that's
I have nothing to add for this. For machining in two setups, for example, green turning of gears, duo machines with two workspaces are used. Unfortunately, it's not quite as simple as shown in the video, but you see the principle. We take two single machine beds and put them together and add then only one control and one peripheral items like the hydraulic, pneumatic and energy container. So this means also a duo machine consists of two separate working areas and they are independent from each other in their movements.
Peter, there is one question. I don't know if you can. Can we answer this during this video shortly? What are the measurement accuracies and tolerances can be achieved with the measurement probes?
Yeah, the measurement probe have an accuracy of 2 to 4 microns. So as you already explained, we cannot use it for this official measuring, but we can check where the trend is going on the tool life, and then, for example, can have this measuring cycle every 10th or in every 5th part, whatever is required.
Okay, thank you for this. So yeah. The video is over. No?
Okay, then start the video again. So you see here the machining on a duo machine where the left spindle do the operation 10 while the right spindle is doing the operation 20. In the meantime, the shuttle is presenting the raw parts to the spindles and then the parts are turned by a turnover unit outside the machine. All parts handling inside the machine is carried out with the transport shuttle and all the rotating and turnover is done outside the machine. We have the possibility to do operation 10 and operation 20, as well as we can do, for example, on both spindles the same operation. And then we can also have the possibility that we are running simultaneously. This means that both spindles are doing exactly the same in the exact same time.
And Peter, if I can step in here shortly, there's one more question regarding the control system which we can offer for this machine series. Is there something special which we have to?
Yeah, the machine can be offered with Siemens control and with Fano control.
But we have to be open that the highest share is Siemens for this machine series.
Yeah.
Okay, and then one more question. If we look here to the turret, yeah, we have here a turret. We see there we have normal turning tools, clear, and we have also driven tools. Which options are possible on the machine series?
We have in standard the VDI tooling interface as well as the BMT interface. And then we can also have a CAPTO system which is called CAPTO Direct Integrated. This means we can then have the clamping units for the tooling already installed into the turret disc.
Okay, there is one more question, Peter. Excuse me. How we compare two VL machines with L shuttle versus VSC duo setup, footprint and costs? So Peter, perhaps I will answer this question directly by myself. So regarding the footprint, the VSC is a little bit smaller, or you need a little bit less footprint, and from the cost side depends then how the VL machines are automated, if they have only L shuttle, and if the VL machine is executed with Fano compared to Siemens with a VSC, then of sure we have some cost, some price advantages a little bit with the two VL machines. But it's not so big, and This we can discuss offshore in a private conversation later on if you are interested. But the differences are not so high. That's only what is the big difference. A VL machine, we are producing not only on a customer demand, we're producing VL machines where we can realize quicker deliveries, but we cannot realize many customer specifications, which we usually doing on a VSC. Many VSC machines are built according to the specifications of big customers, and that's with the VL there we are a little bit more limited. So that's the biggest thing. And one more question, it's Peter, if it's okay, I will answer also directly. What are the main differences between the VSC and the VT series? Important is both are vertical machines. But if we look to the VSC, Peter explained it already, we see it also in the simulations. The spindle going out of the work area and pick up the workpiece and going back to the work area and machining then. That's the VSC. The VT series, it's a little bit different. They are not the spindle, bring the workpiece into the area there. The turret have a gripper, and the gripper bring the workpiece into the work area to the spindle and cutting then. And as well, a VT is a machine where you can do different workpieces, mainly are designed for shafts, but you can do also some shorter workpieces, and you have the possibility to turn with 4 axes because you have on the right and on the left side a turret, also driven possible, and there you can do 4 axis turning. In the VSC you have only this one turret. That's are the main differences. Offshore, the VSC from the design is a little bit stronger for the chuck production, and the VTC have really good advantages for vertical shaft turning. And if you compare a VTC with a horizontal machine, for example, with 4 axes, the footprint is really small. You have an automatic loading and unloading, and you can do also, for example, you have a Y-axis that you can do scroll-free turning and so on. Yeah? So that's the main differences, but important for both machines. We're doing all in our production facilities. We do all our critical components by ourselves. The VTC using as well a mineralite machine bed, and that's all the advantages which we have there. We have also on the other machine. Okay, I hope I answered this question, and take over again to Peter.
Okay, we will continue with the automation solutions for the VSC machines. Regardless of whether the machine has 1 or 2 spindles, or if you have a single or a duo machine, the workpiece is fed to the workpiece spindle using the shuttle. The workpiece are fed to the shuttle, for example, by a gantry loader, by conveyors, or for example by a robot cell. The workpieces are turned between the operations, between operation 10 and operation 20, outside the machine, and therefore we have no influence into the cycle time. We have the possibility to have the shuttle on the left side of the machine, on the right side of the machine, as well as we could have the solution to have, for example, the in-feed conveyor or the raw part feeding from the left side and the finished part feeding then on the right side of the machine. So we are flexible in the part flow. We can have outside the machine, for example, also orientation units that we can place the part in a specific way, or that we can check if there is a special contour on the raw part which have to be detected for later drilling holes or something like this.
Peter, there is one more question regarding processing in the different work areas. Can different types of processing be carried out out in the work areas? Where are the limits, e.g. tool change during simultaneous machining? think we answered a little bit already, but what can you tell or how you can answer this question?
Yeah, if we do operation 10 and 20, we have different operations inside the machine and inside the working areas. So this is a usual way to machine on the VSC Duo machine, but it makes not really sense to have two total different parts on the machine. This is not the usual way we are using these systems.
But yeah, correct. But what we can state it, if we do, for example, OP10, which we later see as well for brake disc, where we do this on a Duo, it's also possible that OP10.1, perhaps you change a tool, and OP10.2, you still producing. Yeah. So you can getting every time turn parts in the time where you're changing the tool on the other side of the work area. Yeah. That's, I think, also a really important statement. Okay.
Then we see here an example layout of a VSC 250 Duo, including the in-feed and out-feed conveyor, as well as a gantry loader for feeding, for turning the part by 180 degrees, and also for discharging. We see here also the chip conveyor, which can have his outlet to the left, as shown here. Also can be on the right side, or can be also be on the rear side of the machine. The same is with the shuttle. The shuttle can be look out on the left side, on the right side, or as already seen on the other slide, we can go through the machine. We see this as an animation. We see how the gantry loader take the first raw part and place this on the first pallet, then take the semi-finished part, rotates this by 180 degrees and place it on the third pallet, and then take the finished part to bring it back to the outfeed conveyor. Then the parts are presented to the main spindle by the shuttle, and the shuttle picks up the raw part for this operation, as we have seen here. Then we do the turning and drilling operations which are required on the part.
Peter, that's also one more question which is not easy to answer. But in the terms of quality, achieved performance, stability, then I think there is some typing error. That's a liability, I think, of machines. How we can position VSC in relation to VL? I will also, I do it by myself, the answering in this case, idea. I think. Yeah, it's if we look on the shop floor and make the same part on both machines, we will reach the same quality. Yeah, that's fact of sure. There is some from the design, from the temperature behavior. There are some differences. Of sure, we saw this gantry type design on the VSC. That's really stable. That's the most stable design in the world for pickup turning machines. And the VL have also really stable design to do also the mineralite bed, but there you have to do a little bit more take care than for compensation if you are turning something. But if we compare the reachable tolerances, they are comparable. There is some differences. The VSC, like also the title of this webinar is for really high series production. There you, at minimum, you changing between the part families. You see the access to the work area is not designed for a daily change of the fixture and also totally new setup, the tools and so on. That's on a VL machine. It's the access to the work area is much more opener, and there is also easier to change the clamping fixture, and as well the VL is in standard equipped already with the O belt, with the O conveyor belt, which means you can put there 20 parts, row parts, and then the machine can work independently. Only with the pickup you don't need additional shuttle, and that's on the VSC. It's for really high series production topics designed. Peter, do you have to add something for this?
I think you have already mentioned that the VL is a standard type of machine, which is more or less coming from the shelf with already good solutions for automation in it, while the VSC series is used in specific and customized production surroundings, starting with technical specifications which have to be fulfilled, or with special automation solutions which then have to be realized.
Okay, thank you. I think we have answered this question on a satisfying way. No, that's the one more question. Oh, that's going fast. That's the point. From what quantity of I think yearly production quantity do the machines pay off? How do you deal with changing workpieces? What is the effort on the retooling of new workpieces? I think the first question, that's depending of sure if you have a really smaller diameter, if the cycle time is lower, you need a higher number of workpieces, or a higher quantity. Later you see we have truck wheel hubs. Of sure they don't need so high quantity, but in general, what Peter and myself already stated, of sure normally they are running families. We execute the fixture with quick change options, so that, for example, the clamping jaws are really fast to changing. Of sure, if we are changing the whole clamping fixture, that's more difficult as, for example, on a horizontal machine. But it's also a normal process that we agree with the customers to a certain setup time between part families, for example. That's you cannot say 30 minutes or 45 minutes, depends from the application. But in the case we come together with the customer, we agree here normally also to setup times of a machine. So that's we don't talking about hours in this case. Yeah. Okay. Step to the workpieces, Peter, please.
Yeah. Okay, to give you an impression of the machine in action, we would like to show you a few examples. We are starting with machining of couplings in the field of oil and gas production. The casing and tubing pipes are inserted into the boreholes, and these pipes are connected with couplings. The coupling sizes range in nominal diameter, which we can machine as between 2/3/8 and 13/3/8, with a raw part length of 350 millimeter and raw part weight of approximately 65 kilograms. You see here the video of a VSC 500 machine. Here we have the infeed via a conveyor. Then the part is gripped by a pick and place and turnover unit and placed on the shuttle and then presented for the first machining. Here you see the pickup cycle to pick up the part from the shuttle, and then we have the machining. We have on this type of parts very high cutting depth, and therefore there are high torques required. We have high chips accumulation, which falls then directly down into the chip conveyor, or sometimes we have also a chip channel underneath the machine. You see very good here that the handling is done in parallel to the machining time, and we have no influence to the machining cycle itself. The motor spindle here on this VSC 500 can have up to 2000 Newton meter torque and with 86 kilowatt of power. On this special application we have a reverse clamping of operation 10 and 20 as these both operations are the same. And then we can use the same clamping, chuck change parts and tooling.
Peter, now it looks like this is the machining or the process looks like not so complicated. That's only in brackets, that's only threading. Can you state it there's something? It's correct or?
Yeah, it's not only just make a thread inside the coupling. So every supplier have a special specification of his thread, and he wants that we recognize this and do the parts exactly to this. And then also some sealing surfaces are very special on this part. It looks very simple, but it isn't like
it's
this.
Demanding, yeah. Okay, thank you for this.
On the commercial vehicles, we have also different parts which are produced on VSC machines. So we have the disc brakes, the brake drums, wheel hubs, gear wheels, as well as truck differential housings. And we will have a look on one of these truck differential housings. They are normally split or two-part differential housings. Here, for example, we have the cover on a VSC 400 Duo, producing the part in two clampings. On the right pictures, we see the possible automation system. We have here the raw part presented to this turnover unit on a pallet. The pallet is equipped with a pin so that we have a pre-location of the raw part prior to loading onto the machine shuttle. During operation 10 and 20, we have the turnover, and then the part is ready for operation 20. We have also here a video from differential housing. Here, special on this differential housing is that we have 4 half bores, and we have discussed it before. We can check the position of this bores with the touch probe that we have the equal stock removal on the contour. This special machine which we see here is a VSC 400 with an additional y-axis also on the cross slide, and we will see it later in the movie. We have on the rear side a milling spindle where we then can mill the half bores. Because of the 3 axes in the cross slide, we can also, for example, mill or drill holes out of the center, radial holes, for example. And what we see later, we can, in this case, we can deburr the contour of the half bores by interpolating X, Y, and Z axis. We are now moving to the milling spindle, which is in the rear side of the machine. Then the pre-milling of the half bores. Now we change to the deburring, and here you see how the cross slide is moving with all 3 axes to make the deburring process on this contour.
Peter, now I think that's we see here air number, yeah, no chips, also no cooling. How is it if we look to? No, sorry that I jump in this interesting broaching process which we see here. Yeah, that's really special. This radial broaching process, but that's what we do here on this machine. So Peter, if we look, how is the share or what are possible? We can use dry cutting on the machines, wet cutting, and what do you see? How is the share what we are doing?
I think it's more or less 50-50. So we have dry cutting machines as well as wet cutting machines. There is no difference inside the machine between dry and wet cutting. On the wet cutting, we normally use the emulsion, but we have also machines equipped with cutting oil. Then we need also the fire extinguisher inside the machine, and we need an explosion detection, and as well we have machines which are equipped with a minimal lubrication system.
So there we are flexible and we follow to the customer requirements. We can do everything what is requested.
To the requirement of the cutting process, which normally gives.
Okay, thank you for this.
Brake discs and brake drums are required regardless of the type of the drive of the car. So it doesn't matter if there's a combustion engine or an electric drive. At the end, you should bring your car to stop. And we do this process, the soft turning or the turning and the drilling, also on the VSC machines. Normally we have 3 to 4 operations. It's depending on the output of the machining line. On the right picture you see the possibility of a raw part feeding by a robot. This robot here is equipped with magnetic gripper so that he can grip the part coming out from the box and place it then on the in-feed conveyor. Between the machines we have the turnover stations which flip the parts from first to second operation. We show you here an example of a machining line for light commercial vehicles. We are turning here in 3 operations on 3 VSC 400 Duo machines. This means on every Duo machine we do one operation simultaneously. So the first machine do the operation 10. It's returning the first side of the brake disc. Both spindles are running simultaneously. Here on gray cast iron, depending on the quality of the casting, we have normally dry cutting and we are using ceramic inserts. Between operation 10 and 20 we have the turnover station. Here we turn over the part over this funnel so that all the chips falling directly down into the chip conveyor. Then we have an collet chuck here in the machine and we doing the second operation.
Peter, if I look here to the work area, we see this clamping fixture. That's also, I think, an important point from EMAG. So if we have serious solutions, of sure we're using the serial clamping solution which we can buy on the market. But what is our big advantage compared to somebody else?
Yeah, we have also our own design and production or manufacturing of work holding systems. So for strategic parts or for critical parts or where we can get no work holding on the market, we are then designing and producing our chucks by ourselves.
Designing and producing, that's important. So also later for refit of the clamping fixtures, we have here really short ways for you as our customers to refit the clamping fixture and so on. Yeah.
The same we have on the truck. Also the truck need brake discs and brake drums. The brake discs for sure are a little bit bigger. So we have here the VSC 500 as a possible machine. Also depending on the output and the machining task, we have sometimes one operation or we have several operations. So in this example, the shuttle of the machine is loaded and unloaded via the gantry loader, which you see here in the movie. We place, in this case, the raw part direct onto the shuttle without a pallet, because we are turning the lower face in this operation. So there's no problem if we have maybe some scratches now in the part, but the finished part for sure requires a pallet to save the lower face before any scratches. This would be not allowed to have this then.
Peter, I will remember a question out of the webinar yesterday in German language, and there was the question, what's going on with the VSC machine? Now we saw only turning machines, turning operations. We are able also to do combined machines, hard turning and grinding on such machine concept.
Yeah, similar like we have seen on the milling spindle before, we can add a grinding spindle and then we can combine, for example, a hard turning, maybe for example, a hard turning of a bore, of a gear, and then a finished grinding process, and then we have this combined hard turning and grinding process. We can have this on the VSC also as a possibility, yes.
Okay, and there I would like to add, VSC is one solution for hard turn grinding machines, but of sure we have as well the VLC basis for where we do grinding and hard turning, and there we have possibilities to going up to 3 grinding spindles and 1 turret. So there we are also really flexible for hard turning grinding operations. This was only a side step from my side for a question which came up yesterday.
So, quality is always in the detail, and we see it here as a conclusion, and I want to summarize it once again. We have the machine body with the 2 side walls, and the attached cross slide give us a symmetrical machine design. We have minimized thermal influences because of that. We have a dissipation of the machining forces. We have the reduced vibrations because of the mineral-lit machine bed. We have the integrated machine cooling system, and we have many automation solutions which can be realized outside the machine by robots, by gantries, and so on.
Peter, thank you very much. This conclusion gives again a good overview about the special components and designs of these machines, and showing us as well why machines of this concept running more than 30 years, because it's still machining existing which we delivered beginning of the 90s. So that's showing these components are really designed for a long lifetime, and yeah, that's really important topic for the machine series VSC. Thank you very much, Peter. And if you have some more questions, please feel free asking it into the chat that we can answer these questions. Okay, I heard that no more questions, so I would like to thank you very much for your time. I hope it was interesting, and we look forward to welcome you on our other webinar. And important also, we spoke about the retrofit of spindles. You are welcome also to register and visit us at our open house retrofit in Eislingen, November the 29th. So go to the webpage and register yourself. So that's from our side. Thank you very much for your time, and have a good day. Bye bye.